In this video, we will learn to solve rational inequalities. This is AP Precalculus topic 1.8. If you appreciate this content, please don't forget to hit that like button. Remember that a rational function is the ratio of two polynomials. So a polynomial divided by a polynomial. We first learned about polynomial inequalities back in topic 1.5. So if you need a review on that, go back and watch those videos. Here are two important traits of a rational function. A rational function will equal 0 when the numerator is equal to 0, and a rational function will be undefined when the denominator is equal to 0. When we solve a rational inequality, we will need to identify where the function is equal to 0 and where the function is undefined. Here are the steps for solving rational inequalities. You can pause the screen and read over this or take notes if you need to. I'm just going to show you. Example 1. I'm going to call this expression over here on the left f of x. We need to start by finding the zeros of f of x. So label it like this. F of x is equal to 0 at a function will equal 0 when the numerator is equal to 0. So that'll be at x equals 2. Next, we need to identify where f of x is undefined. That's going to be where the denominator is equal to 0. So that's at x equals -6 and x equals +3. Now it's time to make a sign chart. We need a row for every factor. We have 3 factors, so I have 3 rows. And we need a vertical line for each one of these critical values. That includes where f of x is equal to 0 and where f of x is undefined. Always label your sign chart. Let's just call it f of x. And we will list off the factors down the left-hand side. So we have x minus 2, x plus 6, and x minus 3. We will list these critical values across the top in order. This is a number line. So least to greatest. So we have -6, and then 2, and then 3. Next, we need to decide whether these factors are positive or negative in each interval. The factor of x minus 2 gave us the 0 of 2. So this is the only place where x minus 2 might change signs. If you think about it, x minus 2 is negative to the left and positive to the right. X plus 6 gave us a 0 of -6. This factor is negative to the left of -6 and positive to the right. X minus 3 gave us a 0 of 3. This factor will be negative to the left of 3 and positive to the right. How about the overall sign of f of x? We are counting the negatives. If there is an odd number of minuses, f of x will be negative in that interval. So f of x will be negative in this first interval. F of x will be positive in the next interval because we have an even number of negatives. And negative in the next interval and positive in the next interval. So will the solutions be where f of x is negative or where f of x is positive? We are looking for the values of x that will cause f of x to be greater than or equal to 0. So the solutions will be in the intervals where f of x is positive. So the solutions will be in this interval and this interval. Now what about the endpoints? The -6, the 2, and the 3. Will these be included? Well, yes and no. Because we are looking for values of x that cause f of x to be greater than or equal to 0, we're going to include any values that cause the function to be equal to 0. F of x equals 0 at x equals 2. So we want to include that. So whenever I do this interval, I'm going to show that 2 is included by putting a bracket on that one. A parenthesis means that that particular endpoint is not included. However, where f of x is undefined, Well, that's not going to be included. An undefined value will never be included in the solution set. So we will put a parenthesis on the -6 and on the 3 to show that these undefined values are not included in the solution set. So the final answer will go like this. This interval from -6 to 2 will be written this way. Then we say union, and now we need to pick up this other yellow interval, which will go from 3 to infinity. So this is the final answer. Example 2 needs to be factored first. So x squared minus 4 factors as x plus 2 times x minus 2. The denominator is going to factor as a binomial times a binomial. X squared will factor as x times x. 25 will factor as 5 times 5. Inner plus outer must equal the middle, so we will need a -5x inner and another -5x outer to make -10. So there we factored everything. Now we need to list the values where f of x is equal to 0 and later where f of x is undefined. F of x will be equal to 0 when the numerator is equal to 0. So that's going to be at x equals -2 and x equals +2. How about where f of x is undefined? Well, that's going to be where the denominator is equal to 0. So that's going to be at x equals 5. We don't need to write it twice. You know what? However, now that I think about it, so as I get ready to make the sign chart, because the x minus 5 appears twice, it has a multiplicity of 2, it would be better, I encourage you to write this as x minus 5 squared. So I'm just going to erase that and write it that way. And that's the way I want to see it on your sign chart. So x minus 5 quantity squared. Let's make the sign chart. Your sign chart should be set up like this. So let's decide whether these factors are positive or negative in each interval. The factor of x plus 2 gave us the 0 of -2. This factor will be positive to the left, negative to the left, and positive to the right. X minus 2 gave us a 0 of +2. This factor will be negative to the left and positive to the right. The x minus 5 squared gave us the 0 of 5. However, that doesn't really matter because this factor is being squared. Therefore, this factor will be positive in every interval. When you square even a negative number, it becomes positive. What about the overall sign of f of x? It will be positive in the first interval because of the even number of negatives. Negative in the second interval, odd number of minuses. It will be positive in the last two intervals, nothing but positive. We are looking for the values of x that will cause f of x to be less than 0. So the solutions will be in the intervals where f of x is negative. Will the endpoints, -2 and +2, be included? Well, this is less than 0, so we are not interested in the values that will cause f of x to equal 0. So we do not want to include the -2 or the +2. So we will use parentheses when we write the solution to show that these values are not included. So in interval notation, we have -2 to 2. Okay, that is the solution. This is not an ordered pair. This is an interval. By the way, I'm not going to do this every time, but we could also write this as an inequality. So as an inequality, we would say -2 is less than x, which is less than +2. I prefer to write things in interval notation. Example 3. I want to say where is f of x equal to 0. That would be where the numerator is equal to 0, but the numerator is a constant. It will never equal 0. So maybe I'll just write none right here, or you could just skip it. However, we can talk about where f of x is undefined. That's going to be at x equals 3. So this is my only critical value. Let's make that sign chart. This will be a small sign chart because I only have two factors, 2 and x minus 3. And I only have one critical value, and that is 3. Don't forget to label the sign chart as f of x. Now we decide whether these factors are positive or negative in each interval. Of course, the constant 2 is positive in every interval. X minus 3 will be negative to the left of 3 and positive to the right. So the overall sign of f of x is negative in the first interval and positive in the last interval. Will the solutions be where f of x is negative or where f of x is positive? We want the values of x that will cause this expression to be greater than 0. So the solutions will be where f of x is positive. Will this endpoint be included? Well, no. 3 is undefined, so undefined values will never be included. Even if it wasn't undefined, we only want values that will cause f of x to be greater than 0, not equal to 0. So no matter what, this will not be included, and we will show that with a parenthesis. So the answer will be 3 to infinity, like this. There's your interval notation. Okay, one more time, and I don't have time to do this every time, but as an inequality, we would write x is greater than 3. So this is equivalent. Example 4 can be factored a little bit because we have a GCF in there. So this is going to be 4 times x plus 2 over x plus 5 is less than or equal to 0. Where is f of x equal to 0? That'll be wherever the numerator is equal to 0. In other words, x equals negative 2. How about where f of x is undefined? That's where the denominator is equal to 0. So x equals negative 5. Time to make a sign chart. Set up your sign chart like this. The factor of 4 is always positive because it is a constant. X plus 2 gave us the 0 of negative 2. It will be negative to the left and positive to the right. X plus 5 gave us the 0 of negative 5. It will be negative to the left and positive to the right. The overall sign of f of x will be positive in the first interval because of the even number of negatives, and it will be negative in the middle interval because of the odd number of negatives, and positive in the last interval. We are looking for the values of x that will cause f of x to be less than or equal to 0. So the solutions will be in the interval where f of x is negative. Because of the or equal to 0, we will include the endpoints where f of x is equal to 0. So we will include the negative 2 with a bracket when we do our solution down here. We will never include a value where f of x is undefined. So that will get a parenthesis. So negative 5 to negative 2, parenthesis, bracket. Example 5. Where is f of x equal to 0? That'll be where the numerator is equal to 0. That's at x equals 1 and x equals negative 2. Where is f of x undefined? That's where the denominator is equal to 0, so that's going to be x equals 2. Sign chart. Set up your sign chart like this. X minus 1 gives us the 0 of 1. It's going to be negative to the left and positive to the right. X squared plus 2 gives us a 0 of negative 2, but that doesn't really matter because this factor is being squared. So it is going to be positive in every interval. X minus 2 gives us a 0 of positive 2. It will be negative to the left and positive to the right. The overall sign of f of x in the first interval will be positive because of the even number of negatives. It'll be positive in the next interval for the same reason, and negative in the next interval, and finally back to positive. We're looking for values of x that will cause f of x to be greater than or equal to 0. So we want the intervals where f of x is positive or equal to 0. So we won't actually need two separate intervals for this first interval and the second interval because they are both positive, and because of the or equal to, we are also including the endpoint. This is really just one big interval, including the negative 2. In fact, because the endpoints are included, for this endpoint right here where the 1 is, we're going to use a bracket on this to show that this endpoint is included. Now, we are not going to use a bracket on the other endpoint, this 2, because x equals 2 is the point where f of x is undefined. An undefined location will never be included in the solution set. So that will get a parenthesis no matter what. Time to write the final answer. So this first fat interval here is from negative infinity to 1 with a bracket. And then union 2 to infinity with all parentheses. So that's it for example 5. Example 6. Where will f of x equal 0? Nowhere. Because a function will equal 0 where the numerator is equal to 0, but this is a constant which can never equal 0. Where is f of x undefined? That's where the denominator is equal to 0. That will occur at x equals 1. Sign chart. Set up the sign chart like this. We have a row for every factor, and we have a vertical line at our one critical value x equals 1. The first row, the constant of 1 is always positive, so just put plus in both intervals, and the factor of x minus 1 squared is also always positive. Because it's being squared, it's going to turn even a negative number positive, which means the overall sign of f of x will be positive in both intervals. So we are looking for the values of x that will cause f of x to be less than or equal to 0. So we're looking for values that will cause f of x to be negative or equal to 0. There are no intervals where f of x is negative, and even at this one critical value, this is not a number where f of x is equal to 0. This is where f of x is undefined. So there are no values of x that will cause f of x to equal 0. So there are no solutions to this. Sometimes that happens with inequalities. Example 7. The graph of the rational function f is shown in the figure above. Use the graph to solve the following inequalities. Part A, f of x is less than or equal to 0. F of x is equal to 0 here and here. It's less than 0 wherever f of x is below the x-axis. So that's going to be on this interval and on this interval. So this first blue piece goes from -3 to -1. So be careful, this -3 is an asymptote. The function never reaches this vertical asymptote. So I'm going to use a parenthesis on the -3 to show that -3 itself is not included in the solution set. However, on the -1, this is where f of x is equal to 0. And we want to include such values in the solution set because we want to know where f of x is less than or equal to 0. That's -1. Union. And then similarly, this interval goes from 2 to 3, bracket, parenthesis. So that's the answer to part A. All right. Part B, f of x is greater than 0. Let's erase this. So greater than 0 is above the x-axis. So we saw that it was equal to 0 at -1 and 2. So I'm going to put an open circle here because this time the endpoints are not to be included. But f of x is above the x-axis between these 2 points. And, of course, it's above the x-axis for this whole interval and this whole interval. So, this solution is going to have 3 parts to it. This interval on the left goes from -infinity to -3. The -3 will get a parenthesis because there's an asymptote here. The function never reaches -3. Do not include it. And then we have this interval in the middle from -1 to +2. We will use parentheses on both sides because these are open circles. All right, these are not places where f of x is greater than 0. These are places where f of x is equal to 0. That's not what we want, so we will leave the endpoints out. And then the final interval goes from 3 to infinity. All right, so that's the solution for part B. For part C, we want the values of x that will cause f of x to be greater than or equal to 1. So I see this horizontal asymptote right here. There are no values that will cause f of x to equal 1. This is a horizontal asymptote. The function never reaches 1, even though it kind of looks like it over here. It never does. So let's just focus on the greater than 1 part. Well, both of these branches are above 1, greater than 1. So these 2 intervals will be the solutions. So we will have -infinity to -3, union 3 to infinity. And that's it. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.